So this lesson focuses on being able to determine the area of the base of rectangular prisms. So it's the first part of our prism lesson on volume. And the reason we're doing this is so that we can be able to calculate volume. And this is our standard, and we are looking at different types of problems that we can do, both real world and just kind of generic ones. Some of the vocabulary that you need to make sure that you know are, what is a prism? Okay, so a prism is a solid object. It has two congruent and parallel polygon faces. It has faces are the polygons that connect to make the prism. It has lateral faces. The lateral faces are what connect the bases. The bases of the prisms are the two congruent polygons which are parallel to each other that give it the name. Cube is a special name for a rectangular prism, and it has 6 congruent faces that are all squares. A rectangular prism has 6 rectangular faces versus a triangular prism, which has 2 triangle bases. So this is a triangular prism, and you see down here it says that it has the 5 faces. And when we're looking at it, I see it as triangle. So that's one of its bases. And if I flip it over on the other side, that's its other base that's parallel to it. If I look over here on the right, I see its net. And the net is just taking it and flattening out. So if I hit play, you can see how it becomes that triangular prism. So the lateral faces are the rectangles, those 3 rectangles, as I rotate it, that connect the rectangle that are the 2 bases. So altogether, when you look at the net, you can see the 5 faces. 1, 2, 3, 4, 5, 2 triangles and 3 rectangles. The rectangles are the lateral faces, and the 2 triangles are the bases. So now going back to our vocabulary, okay, we can see what the faces and lateral faces are. And the bases were the faces that were the triangles on that specific triangular prism. Now on a rectangular prism, when all of the faces are rectangles, it really doesn't matter which one is the base and which one's not the base. So any base on a rectangular prism could be the base. Pentagonal prisms, we're not going to be doing this year. You do it more in 8th grade high school. But get those names from the 2 pentagons that make up its bases. And then we have octagonal, and we can go up to any type of polygon that we'd like. We can even have a prism that's base is a parallelogram. I don't know what you would name it though. Parallelogram prism, I guess. Okay, so now let's go ahead and go over volume itself. So one thing you got to remember about volume is talking about how much fits inside. So if we go ahead and we go to this website here, so here's the net for a rectangular prism. And if I go ahead and fold it up a little bit, you can actually see the rectangular prism. So what we're going to do is we're going to fill this up a little bit. Sorry. And see what okay, so 1 cube. So that's how we measure volume. So that's 1 cubic unit is not going to fill up this entire rectangular prism. So if I go ahead and add another cubic unit, and another, so that 4 fills up 1 row. And it looks like I can fit more rows on the bottom. So if I go ahead and I fit more rows, so now I have 1, 2, 3, 4, 5 rows of 4. And now it looks like I can fit more layers. So if I go ahead and fill up, what I've done is I've gone 4 by 5 by 3 to fill up the entire rectangular prism. And that's how we get our formula. And it's called cubic units when we measure the capacity for something's volume. So in the formula, V stands for volume. We use capital letters for length, width, and height, and that's so we don't confuse it with the lengths, the widths, and the heights of the actual faces. So the length of the base, the width of the base is the L and the W, and the capital H represents the height of the prism. Later on, when we start doing triangular prisms, we're going to have two heights. We're going to have the height of the prism, but we're also going to be talking about the height of the triangle, and that's where we have to differentiate that height with a capital H and that H height, lowercase h of the triangle. Okay, so let's go ahead and calculate our volumes. So first we have just a general box, nothing special about it. So I start off with my formula. Remember, when you're showing your work in geometry, if you require a formula, you write the formula down to let people know this is the formula I used. Then we substitute, we replace. Now, usually we kind of say that the base is what the prism is sitting on. So here's my base, and it's that rectangle at the bottom. And so it's 10 3/4 by 5, and either of those could be the length and the width, it doesn't matter. So I'm going to substitute 10 3/4 times 5 for my length and width. And then my height is usually going to be how tall it is. So that would be 6. Okay, evaluate means do the math. So first I'm going to take my fraction, I'm going to make it into a mixed number, an improper fraction, excuse me. 10 times 4 plus 3 would be 43 over 4 times 5 over 1 times 6 over 1. I'm going to simplify, and you could use a calculator instead for this. And there are some calculators on Google Classroom links for you. So I have 43 times 5 times 3 after I simplified, which gives me 645. 2 times 1 times 1, which is 2. And when I go ahead and simplify that, it gives me 322 and 1/2. So my volume is 322 and 1/2 cubic feet. So make sure you use the correct units. Okay, so now we have a cereal box. So we need to know how much fits in there. Now we know, of course, cereal boxes never filled up all the way, but if they actually could fill it up all the way, how much would fit in? So we substitute. So again, usually the rectangle at the bottom of a rectangular prism is going to be its base. So we're going to use 18 and 8 as our length and width, and how tall it is usually going to be our height. So now we're going to evaluate. So we're going to do 18 times 8 times 32, and that gives us 4,608. And now we write our answer with our units. So that's 4,608 cubic centimeters.